Good morning, everyone. Welcome to today's session, Build an AIOps Platform at Enterprise Scale with Google Cloud. My name is Sharon. I'm a product manager here at Google. I'm happy to be joined on stage today with Bruno, who's a principal architect at Google, as well as Michael, who is a staff security engineer at Uber.
For 8 a.m., we appreciate that. Thank you.
All right, thank you. In today's session, we'll cover a lot. We'll talk a little bit about what is AIOps. We'll talk about infrastructure intelligence. We'll give a customer example of how they were able to build a custom AIOps solution. Then we'll talk about how you can get started really quickly with AIOps with Active Assist. Michael from Uber will then join us to talk about his experience there. And then we'll give a little hint at what's to come on Google Cloud. And so with that, let's get started with what is AIOps. So let's first start with a problem that I think everyone in this room should be familiar with, where you have an outage and you have to figure out what went wrong. Did something change recently? What's the root cause of this problem? There's a lot of finger pointing and war rooms trying to solve this issue. And so that brings us to AIOps, which is a term coined by Gartner that refers to the application of artificial intelligence to automate processes and discover problems so that outages and issues that we just discussed can be prevented in the future. And so our customers know that Google has some of the largest data centers and infrastructure in the world, and we've published books on this, like the SRE book, and customers want to know how we do it. So I wanted to quickly touch upon Google's approach to intelligent operations. We can think of it as divided into kind of 4 sections. The first is that whatever system or platform that you build must be able to see. So it should have basic monitoring and observability capabilities into the data. Then it must be able to think. It should be able to analyze the data, produce insights, then actually take action on those insights, do root cause analysis, provide recommendations, and then finally care, continuously learn based off user activity, and continuously improve the system as well as the data with the ultimate goal of being what we call self-healing. And so with those 4 pillars in mind, I'll invite Bruno up to the stage to talk a little bit more about infrastructure intelligence.
Thank you, Sharon. And thanks, folks, for joining us early in the morning on this very interesting topic for me. So I'm a principal architect, as mentioned before, and I work in the healthcare life sciences space. And one of the things we were trying to do with my customer, Johnson & Johnson, they were looking to automate their operations across the board, including some of the things we talked about. So I'm going to talk a little bit about the platform itself, and then I'm going to get into a little bit more about the use case and the architecture. And then obviously we'll be opening up to the Uber story and talking and having some Q&A after that. So same problem that Sharon mentioned, right? They had a simple problem, quote unquote, right? How do we triage an application outage? Who's to blame? It always comes down to those kind of silly things. Like, where is it because of a network outage? Did a database change that affected a bunch of other systems? Do we need to bring in Google, Oracle, all these different partners, right? Having all these war room sessions, right? It's a very, very difficult problem to try to solve. And one of the most important things you need to do is to figure out, again, based on those 4 principles that Google has, like, how do we get our arms around the data? What's the data that we need for observability? Without the good data, without the good information, we're not going to be able to really triage the problem properly. And it's not an easy task because you're working with different silos, different systems, et cetera. The other thing that's really important, and this is common for all customers, is how do these pieces of infrastructure interrelate to each other, right? So for example, if I was to change a version of a database, it could affect the front-end web applications. It could affect some back-end systems, some other systems we're not aware of. A network change can obviously have a ripple effect across multiple systems. So being able to map what systems are affected by each other and what the relationships are is also key. So data and the relationships between the systems. Now, one of the pieces that you really need to take time, and we did this with J&J, but in general, I think all customers should look at it this way, is what are the pieces of log data and infrastructure data that we need to pull in, right? So I talked a little bit about that before. And it's not everything, it's not so obvious, I guess. If you look at some of the main things we have there, like, yeah, machine logs, application logs, that makes sense, right? Network logs, performance logs, auditing and security logs. But then you want to look at things like synthetic actions. Maybe we want to simulate a strain on the system before we release that new network configuration. We may want to also pull in human sentiment. And this is where some of the Google benefits kind of shine compared to other solutions. Because you could say, hey, I could take data from anywhere and throw it into any solution and start to do this in analytics. With BigQuery, we have the ability to pull in external data sets very easily. We maintain that. Google maintains that for you. So think about, for example, if there's an incident like we have the hurricanes, we have earthquakes in the area, things like that could affect the data center for Johnson & Johnson or for whatever customer, right? So that weather data is actually important for us to plan outages or hopefully plan upgrades without outages, I should say. And then things like human sentiment analysis. So how does human sentiment analysis kind of fit into this? Think about call center information where you're getting a lot of customers calling in and saying, performance on the application's bad or it keeps crashing. You get 2 of those tickets, 5 of those tickets, 10 of those tickets, we have an issue, right? That should be automated. We shouldn't know about the issue after the customer's already suffering, right? So pulling in that information is really important. And we have partner adapters and connectors to things like Twitter, Facebook, so people don't necessarily call the data center. They're just like, oh my God, Bruno's application was really awful today, right? Whatever it is, right? They're not going to necessarily call Bruno.com. By the way, I don't have that site yet, but maybe I'll buy it to find out what's going on. And all that kind of falls into kind of getting to true root cause analysis, feeding in all those aspects of data to try to see where is, the most, support tickets coming from, plus network, plus this. Okay, now we have a root cause analysis because it seems to be a network issue based on these tickets and based on these calls that we're getting in. So let's talk a little bit about a use case where we took this platform and we actually partnered with HCL. They're one of the premier sponsors here today. If you want to meet with them later, I can introduce you. And they talked about, with the customer and with ourselves, kind of an evaluation, like what's the best approach to automating and doing some AIOps. And so the need was, so J&J has an effort going on to reduce their spend and to reduce their operation costs by $50 million over the next few years. They looked at Google as a piece of this to try to automate some of their service tickets through ServiceNow and some other pieces. What they did was a proof of concept and wanted to understand why Google would be good at this. They found the ease of BigQuery. Basically, within a month, we were pulling in ServiceNow tickets through BigQuery, through Looker, having an analytics platform. So we already had a dashboard across a bunch of different systems for them that they didn't see before, as well as starting to triage some of their tickets. So they were like, this is quick, this is easy, let's continue on with this as well. The other key piece, and this is tough with every company, is having a good sponsor. So we were lucky at J&J that we had the head of ops, we have this initiative, and this is like, you guys are gonna do this. No, network team, you're gonna give them the data. Because the first thing they're like, oh, we do this already. Network team, oh, we got it down, we're fine. It's like, yeah, but do you realize that a security change or database change could be affecting your network or vice versa, right? That interrelationship piece is the hard part. So having a good sponsor and also proving it out helped start to break down the silos. And then, what was the customer actually able to do in this case? So they were shooting for 50 million. They were super successful, 200 million savings across the board over the first couple of years. Google was 3.2 million of that. So the only application we did, I think, was ServiceNow. It was a very basic application, and they already were achieving 3.2 million. So this year, we're hoping we're pulling in network logs, Linux logs, all these other types of, device logs are coming into this environment now, and so hopefully we'll improve the system even more. So just to talk a little bit about the approach that we took there, And this is a model that would follow most customers. Again, depends on your partner or yourselves. So first, propose an architecture that works, right? So what are the data criteria? What is the service level criteria? What is it you're trying to really achieve? Kind of what's the best bang for the bucket first, and then kind of what's the future growth? And then basically having the landing zone and the infrastructure to test it out. Okay, it's very easy to do, believe it or not, a proof of concept with this environment. So you can just pull in a bunch of logs, get some Looker dashboards. We have some pre-built ones that already do some of these kind of what-if scenarios and analytics that work really well. Having that whole platform is important. Then the first piece is, okay, let's give some dashboards and observability to people, kind of prove ourselves out. And that was very successful, as I mentioned already. And then what we started to do was start to put the AI in there. So again, with BigQuery and these platforms, we have integration to AI. So being able to do what we call the traffic cop analysis. So think of 15 different ServiceNow tickets got opened about some kind of performance issue, but they're all related around, I'll keep picking on networking. I hope there's not network folks out here that are upset about me using networking as an example, but it's an easy one to use. Like they're all kind of pointing to the network. So we should be able to kind of learn from that, and the next time a ticket comes in, not have to wait for 15 of them. We kind of can group them together, know that there's a network issue. So we already started doing that with some pretty basic models. The next piece that we're looking to do is, and we're actually starting to build out there, is how do we take this platform, improve upon it, and do things like the magical self-healing at some point, right? Right now, we're doing some predictive analytics. So let's see some what-if scenarios. Google does the same thing. When they're about to implement a network change, they actually have a what-if environment that actually tests things out before they push it out. Same kind of things there. And then we also started talking to the security folks. So this started opening the doors to everyone in the environment. So the security team's like, this is really cool. I need to know more information about my audits and what's happening in the environment. And you guys can give us a more full picture of devices that are logging on from device logs, et cetera. And one of the pieces they're looking to do is potentially put Chronicle in there. Because basically you have the landing zone already, you've got the feeds, Chronicle can churn through all that and start to detect cyber threats. iChart architecture, it'll be in the slides for you later for next to download, but this is an example of the platform architecture, pieces of which are implemented today now, J&J. So you can see from left to right, you're collecting different data points. I mentioned that. I mentioned the ability with BigQuery to leverage a lot of public data sources, as well as internal data sources, as well as ServiceNow, as well as they're looking at Teams for pulling in chat. So if people are chatting, there's some issue with something going on, they can pull that in as well. Then the transformation piece, obviously cleaning up the data, deduping, things like that. Then analyzing it. So this is where the strength of BigQuery with Looker comes in, right? Once it's in BigQuery, we can just go at it. And we can actually add some machine learning, which we did. So in this case, we've got some NLP, and we also have some custom machine models that they built to do some of the traffic cop analysis. They're putting in some predictive analytics next. And then, as I mentioned, Looker is the visualization of everything that's going on. The next piece we're also looking to do is, well, this is great for this is actually all for their on-prem infrastructure in their data centers. They're like, we got to extend this to the other clouds next. So this is where Active Assist comes in, and we're going to talk about that later. We're like, well, for Google, we kind of got a leg up, because we can start feeding in the automated AI pieces from Google that already start to detect these things, like network performance, like security monitoring, where maybe this person can have all the security across all these different things, compute monitoring. So those kinds of things. So we're already feeding not just logs from Google, we can actually start pulling in from the AI recommenders and the Active Assist pieces as well. So this is just kind of a brief summary slide of what I mentioned. So really, what the platform did for J&J and for customers in general is kind of bottom up, break the silos. I think that's really important. It's really cool to see after about a year on this project that teams are coming to us. I never thought the security risk management team would come to this team and say, yeah, we'll give you more data and we'd like to work with you. They're always like, stay away from us, it's security, right? That kind of. And now they're like, yeah, maybe we should be working together. They really see, I think people see Google as a leader and kind of modeling what we do in our data centers. to support their own data centers. Again, I talked about the savings and the overachievement, so you can see some real value and some real goals. Okay, with that, I'm going to pass it back to Sharon, and we'll be talking to you later. Thanks.
Great, thanks, Bruno. So we just talked about how one customer was able to build, a comprehensive custom AIOps solution, but what if you were short on time as well as resources? This is a great way where Active Assist is already available to you today on your GCP projects, and it's really easy to integrate into any custom AIOps solution, as well as it addresses some of the use cases for AIOps, such as advanced business insights, predictive capacity management, and finding the needle in the haystack. So Active Assist have insights and recommendations that help you optimize your cloud across a variety of value pillars, whether it's you want to optimize your cost, improve your reliability, improve your performance, etc. So like I said, they are available to you today on your Google Cloud projects. You can see them on the UI, API, CLI, or you can export them to a BigQuery dataset. And so with that, I'll invite Michael onto the stage, who will talk a little bit about how Uber was able to integrate with Active Assist in their own intelligent automation solution.
Awesome. Thanks so much. Hi, folks. I'm Michael. I'm a security engineer at Uber. So I'm going to talk about a few use cases that are first and foremost driven by security, but also by some other optimization requirements. So first, a bit about our journey first. How did we get to Active Assist in the first place? So we, as a company, we started using Google Cloud around 2017 or so. Back then, when we tried to do optimizations of our infrastructure, pretty much as Bruno was saying earlier, right? A lot of manual labor. So we would need to look at the logs, query the logs into using BigQuery, and then trying to do the optimizations manually. So, one example is looking for inactive resources that we want to remove from a security perspective, right? We want to reduce the attack surface, we want to remove unused resources. For that, we would query the logs, right? Look at audit logs. Now, if anyone tried to look at audit logs for the past 30 days, 90 days, it's a bit of a hassle, especially because you need to filter out a lot of the activities, right? There's the kind of observer affecting the observation effect there, so I need to filter out myself looking at the project. There's other projects in GCP that can be using service accounts looking into your project, so you need to filter out that as well, right? So a bit of significant work when we look at these logs just to understand the activity on a particular project. So around 2020, we started using Active Assist for, as I mentioned, for first and foremost, security benefits, but also quickly we discovered that there's also cost benefits and even sustainability benefits. So with that, let's go to the first example. So let's dive a bit deeper into this use case of inactive projects on GCP. Now, organizations such as Uber has thousands, about 2,000 to 3,000 projects at any given day in GCP. So quite a significant scale. We cannot even hope to manually keep track of projects' usage, activity, inactivity. So let's take a look at the left side here. There's 4 different states that we are interested in when we look at a project, right? A project can have an owner, an active owner, someone in the organization, or maybe a Google group. Or maybe this owner left the organization or moved to a different team, and the project no longer has an active owner. So this is bad from a security perspective, right? Also from maintenance perspective. You want to have someone that is in charge of a project. So either orphaned, no owner, or a project is owned. Now, on the upper side here, we can also look at activity. Either a project is currently active, it has resources that are running, or maybe it has resources, but they're not really used, so inactive. So on the left upper side, this is where we want to be. We want to have an active owner to a project, and we want to have activity in this project. If we go down, we can see that if a project is used but is orphaned, well, then we need to find another owner. On the upper right quadrant, right, we can see a project is unused, and we have an owner. So we can talk to this owner and say, hey, looks like this project is not being used. Take a look, right? Maybe you want to delete this project, delete the resources and the project itself. So for that, we built automation on top of Active Assist. I mentioned first we were looking into the logs. It was a bit of a hassle. Then we switched to Active Assist. It's a simple API call to Active Assist, and we get the understanding of whether the project is actually used or not. Also, we get the CO2 emissions from this project, and simple additional call to Cost API, we got the cost that this project consumes. So on the right side, you can see this is an example of a Jira ticket that we create. So we assign it to the project owner, and we say, hey, take a look at this project. You have, looks like unused resources in this project. The project generates so-and-so carbon emissions. The cost is so-and-so, so we motivate the owner to get rid of unused resources. Removing this project, again, reduces the attack surface, benefit to security, benefit to reduction of cost, and sustainability. And then finally, in the red quadrant, down right side, if a project is not used and it is orphaned, generally we can just get rid of this project ourselves. Now, we need to do it carefully, right? Because what if someone uses a project once in a long time, right? Once in a while, and it so happens that the project is not used, is not owned. So generally, we start by blocking permission to the project. We stop the resources before we delete it. So do a bit of a scream test before we actually delete it ourselves. Now, how did we build this? So on the right side, you can see the architecture. It's entirely on GCP, using GCP services. We have a cloud scheduler. Every now and then, triggers through PubSub worker cloud functions. The cloud functions communicate with Active Assist, query Active Assist for project activity, and query billing API for the project cost. Then we store this results in Firestore, and through another PubSub message, we talk to Jira or ServiceNow or Slack and reach out to the project owner saying, hey, take a look at this project, looks like it's not being active. It's not a complex architecture, right? Encourage everyone to, to take a look, and maybe you can build it yourself. I'm sure you can build it yourselves, and immediately reduce the cost and the attack surface. So quite beneficial. Okay, let's move to the next example. Again, we're still in the security world, right? IAM recommendations. So we know that in GCP, we assign roles to project owners, to users. Now, these roles are often overprivileged. Right? It used to be the case that everyone would just ask for the owner role or an editor role. This is not what we want to do. Right? We want to have least privilege. So how do we tackle this? So again, we look at Active Assist, but this time we look at IAM recommendations. And if we see that there is a recommendation of reducing the roles, reducing the permissions, we, again, use, in our case, Jira or ServiceNow tickets to talk to the owner and recommend reducing these privileges, these permissions. So it's completely automated, right? The user pretty much has to just click on accept recommendation, and the unnecessary roles get removed. So you can see on the right-hand side, it's a block diagram of the architecture. Manager, it's just a fancy word for a cloud function that runs a bit of a logic, talks to IAM recommender in Active Assist. Then we decide to take an action based on the recommendations. We attach risk scoring based on the overprivilegedness, right, of the findings that we have. And we decide to either automatically remediate, right, so essentially accepting the recommendation ourselves, or create a ticket and assign the ticket to a user. Okay, so again, reducing the unnecessary permissions, reducing the attack surface. Final example is Compute Engine Recommender. So here we really want to utilize our compute resources, right? We often over-provision compute resources. Now, before Active Assist, it was quite a difficult job. You would, as Bruno was saying, you would have to look at the logs coming from VM instances, right? You would need to understand how much CPU utilization is being done, maybe deploy agents on these instances, right? Today, it's much easier for us, again, just another query, pretty much to Active Assist, understanding whether a VM has not been utilized or is underutilized in terms of CPU or memory. Maybe it has disks that are attached but have never been used. So these recommendations allow us to, again, generate tickets. And in these tickets, we can ask, hey, maybe deattach, remove these disks because it's not needed. Save cost, save on sustainability as well. You can see on the right side, this is how the recommendations look like on Active Assist. And we really see Active Assist as the managed ML or managed AI offering for ourselves. So no more no more digging into the logs, right? Essentially, as I mentioned, just an API query. We see that we have unused resources, or we see that we need to resize an instance, and we can either accept this recommendation, right, and make the change ourselves, or ask an owner, if it's a more delicate change, to do it on their part. Again, reduction in attack surface, cost, and CO2 emissions. So with that, I'll pass it on to Sharon to summarize on AIOps.
Great, thank you, Michael. Okay, so in today's session, just to quickly wrap up, we talked about how one customer was able to build a custom AIOps solution. We talked about how you can get quickly started on your AIOps journey with Active Assist. But I just wanted to give a little quick hint on what's to come. So Google Cloud AIOps tools are coming in 2024. We know that with the surge of AI in developer productivity, that we need to also provide AI to help you set up monitoring, troubleshooting, as well as mitigating future issues. So Google Cloud is investing in native solutions so that you can have tools out of the box. And that's coming next year. And so with that, thank you for attending today's session. I'd encourage you to check out our other sessions if you wanted to learn more about observability tooling, Active Assist, GreenOps. And then if you had further questions, you can also come to our DevOps booth in Innovators Hive.